Good morning everyone. I am Tanushri Dalai from Civil Engineering branch, and today I am going to teach you your Theory 1 paper, which name is Structural Mechanics. So in the previous class we discussed about the numericals regarding axial deformation of the body. Okay, and I have already told you about the elastic constants present in a structural or a body or any kind of member. So today we will discuss about the various kind of elastic constants which are present in a structural member. So now see, what do you mean by elastic constants? So when an elastic body is subjected to stress or load, a proportionate amount of strain is produced. The ratio of the applied stress to the strain generated will always be constant and is known as elastic constant. Okay, so the elastic constant is present in every kind of material which are used as a part of structure. So see, what are the kinds of elastic constant over here? So the first elastic constant is elasticity modulus, and it is also known as your Young's modulus. In the previous class, when we discussed the axial deformation, here also you known about the elastic modulus or Young's modulus, which is denoted as capital E. Okay, so here we will discuss about these things in details. So next one is your Poisson's ratio. Okay, and the third one is your modulus of rigidity, or it is also known as rigidity modulus. And last one is your bulk modulus. So now come to your elasticity modulus. So what is the meaning of elasticity modulus and what is its definition? So elasticity modulus says that according to Hooke's law, when a body is subjected to tensile stress or compressive stress, the stress applied is directly proportional to the strain within the elastic limit of that body. The ratio of applied stress to the strain is constant and is known as Young's modulus or modulus of elasticity. Then Young's modulus is denoted by capital E and its unit is same as the unit of stress. That means your megapascal or 1 Newton per mm square. Okay, that means in simple way you can remember the definition like the Hooke's law says that within an elastic limit the stress is directly proportional to the strain while the body is subjected to a loading condition. Okay, the loading may be in tensile in nature or in compressive in nature. Okay, so here you can see the figure. So the first figure is, it is the original shape of the body. Then while the body is subjected to tensile loading condition, that means in the both sides to apply the tensile load. Okay. So due to the loading condition, the body may deform. Correct. So after the loading condition, the body deform up to this much. This is the deformation part, which is denoted as del L. Okay. So here what will be your value of capital E? That means Young's modulus. So as I told you in before, like your stress is directly proportional to strain. So while you equate a proportionality limit, then you have to give a constant value to that term. Okay. So the capital E is generated from that constant value. Correct. So your capital E equal to stress by strain. Correct. If you provide tensile load, then the formula will be tensile stress by tensile strain. If the loading condition is compressive load, then the stress will be compressive stress by compressive strain. Okay. So in this way you have to put the formula. Then next elastic constant is your Poisson's ratio. So it says that when a body is subjected to simple tensile stress within its elastic limit, then there is a change in dimension of the body in the direction of the load as well as in the opposite direction. When these changed dimensions are divided with their original dimensions, and longitudinal strain and lateral strain are obtained. Okay. So the ratio of the lateral strain to the longitudinal strain is called as your Poisson's ratio. It is represented as the term or a symbol which is known as your mu. Okay. Then Poisson's ratio is maximum for an ideal elastic incompressible material, and its value is 0.5. For the most of the engineering material, the Poisson's ratio will lie between 0.25 and 0.3, and due to it is a ratio of change of dimensions, so here it is a unit less. Okay. So in simple way you can remember the definition as, it is the ratio of lateral strain to the longitudinal strain of a body. Okay. So next one is your modulus of rigidity, and it says that when a body is subjected to shear stress, the shape of the body gets changed. Obviously, when you give a shear stress to a body, then the body is deformed. So that the ratio of shear stress to that corresponding shear strain is known as your rigidity modulus or modulus of rigidity, and it is denoted as capital G, capital C, or you can write as a capital M. The unit of the modulus of rigidity is same as your stress and elastic or Young's modulus. Okay, which is your megapascal or Newton per mm square. So in simple way you can remember it as, it is the ratio of shear stress to shear strain. So you can see the figure over here, and we applied in this figure a shear stress. Okay. So the due to the shear load, the shear stress is generated over here. so that the changing of the body is known as your shear strain. So the modulus of rigidity is defined as the ratio of the shear stress of the body whole divided by shear strain of the body. Okay. So thank you so much. We will discuss next part in the next class. Thank you.